Hello everyone and welcome to a new episode of All Things IDA. In today's episode I'm gonna be talking about adding Python bindings for C++. This is the case where we have some C++ functions or classes that we wanna introduce into IDAPython. And this is when we don't necessarily have to change the IDAPython sources to introduce those new bindings. I'm gonna be using pybind 11 for that because it makes things super easy and with little to minimum dependencies. With that, let's get started. So the framework I'm gonna be using is called pybind. 11 is for C++ 11 and it's a lightweight header only library that exposes C++ types in Python and vice versa. So this library will let us have two ways to communicate between C++ calling Python or Python calling C++. And I'm gonna be using this to write a plugin for IDA, introduce a couple functions and show you some cases. So for this video, I'm going to be binding myPrint and myUtil class. Now, as it looks here, they are really simple functions. In real life, what we do is maybe if we have our own private C++ library, and we want to make the minimum efforts to introduce couple functions from our library into IDAPython. So here, just to illustrate, we're gonna be covering a simple function, takes one argument. Now it doesn't matter how many arguments it has, and a class, just for illustration, it has some member methods and some member variables. Here we have a constructor with a default argument, couple member functions, and so on. So the way I designed this extension plugin, so this is a regular IDA plugin. We're gonna cover all the rest of the plugin stuff, but for now we're focusing on just the pybind part. So the way I designed it is in a table format. So I defined a table called extension table. So it's a vector, and what we have inside is just a function object. You're gonna pass a lambda that takes a py object, and then we're gonna insert new attributes to whatever object we pass. We'll see who will be using that extension table in a bit, but as simple as it is here, if we want to introduce one function, for example, into a certain object, we simply override that attribute. And this is a specific case. We'll see how I set up the caller that uses the extension table. Same, the other entry here for registration is the class, and this is just the pybind syntax, where as well we introduce the myUtil class into the object we pass to the lambda. And here we're selectively passing some member methods and potentially some attributes. For example, here read only ID, read write name, and name is the member variable here. Now for the registration, this function here, we'll see who will call it from the plugin code. But so far this is mainly pybind code. The first thing is we acquire the global interpreter lock. This object will release the lock when it's out of scope. And by design, I wanted to add the class and the method into IDAPy.ext and then I want to introduce myPrint here. So this is my choice. We can introduce it to the built-ins namespace, or we can introduce it to any other object we want. So here, for example, and so on. So that's what I want to expose those extensions into. So after we get the lock, I get the IDA API module, I get a reference to it, and then check if it already has the ext. So we want to put it inside ext. So IDAPy.ext the new stuff we're introducing. So I'm checking if it has already ext. Now you would be asking, why would it have already ext? Because I have another extension I made in the snippet manager if you watch other videos, and that's where I added new functionality into IDAPython, into IDAPy.ext. So if another plugin already populated the ext object, we simply grab a reference. Otherwise, I'm gonna construct a special object. So this is a special object from IDA API that lets us create attributes on the fly. So once we set an attribute that doesn't exist, it will be automatically created. So this is backed by Python code. Now, if you don't want to use this approach, you'll have to use different techniques using pybind. So if we don't have it, then simply create an instance of that and add that object to the IDA API module. Then I'm simply calling the binding methods from the extension table. So here now, if you go back to the extension table, it's receiving the ext object and we're adding attributes to the ext object here. Now, as I said, if you wanted this to go into the built-ins, you simply get a reference to the built-ins module and pass here the built-ins instead. And then that will give you the ability to do something like this at the global namespace. We would be able to do directly myPrint or directly access the class. Now let's look at the plugin code. So a plugin, we read the plugin from the plugin descriptor. So we go to the end, we have the plugin, the regular stuff that make up a plugin. It should have the plugin multi-flag. Plugin fix is important. This flag lets IDA load our plugin and keep it in memory until IDA stops. So as soon as IDA starts to exit, then our plugin will unload. That means if we are in the same IDA session, we keep closing databases and opening them, our plugin will not be loaded and loaded each time. So we register those functions, they stay alive during that session. Plugin hide, if you don't plan to expose any menus in the edit plugins menu, then you can enable the plugin hide. Here, since this is a test plugin, I want to expose the run method and invoke it with the Ctrl+4 hotkey. So I omitted that. And then let's go to that plug mode object. So the regular plugin construction, I'm extending from plug mode, the constructor. So here I'm gonna be talking about that important concept. Why am I hooking to the UI notification events? And let's forget about that for a second. And then when the time is right, when I receive UI init database, it's only then that I call the registration. So like this, I'm waiting for IDAPython to fully initialize, and then I'm registering my extensions. But this event that I used will be firing each time the database is initializing. We open a new database, it will fire again and so on. So I just simply use a static variable to make sure we only register once. I'm gonna be talking about that piece of code as well. But for now, we should be ready to test that as it is. So let's just run it. And here we have it. Let's put this on the side. IDA's loaded. Now I should be able to say IDA_API.ext. For example, myPrintf. And as well, since I'm under the debugger, I can even add a breakpoint at the implementations. So I'm going to put a breakpoint at my print and at the constructor of my util. And let's just invoke it here, for example, testing, and let's run. And here we broke into IDA. We can see here the cursor, this is the message. So the automatic conversion between Python strings passed to the C++ code, and if the C++ code wants to return stuff, this is automatically handled by pybind. And as we said, the syntax is really simple. So to bind a single function, all we have to do is simply name the attribute here. The name doesn't have to be the same as the code name here, so we can expose it anyhow we want. And for the class is as simple as that, really. So it's like a one-liner for basic functions. Couple lines if we want to bind methods in a class, for example. So not too much. And I also added some markers for automation. I'll talk about that in the future, where we can automatically generate this piece of code in that table. So now that we're still suspended, let's let it run. And here we got that. Similarly, if I want to use the class, I just have to refer to the class correctly. If I want to pass a constructor value here, for example, as well as say test, and here we broke into the constructor. And I did expose the ID, which goes to the ID field. So I can say, for example, x.id, and it will show me the ID. This is just as many instances I create, it will increase the ID. So here y.id is going to be 2, and so on. I can here, for example, call member method upper or print line. Let's call upper, say x.upper, for example, lowercase, and let's assign it to a string. And we can see here the string is made uppercase. And here all we had to do is write simple C++ code. We don't have to deal with Python stuff, as I said, to convert back and forth. So this is it, basically, nothing much to it. Now I'm gonna explain some concepts next. So now let me explain some intricacies that I skipped over. Why did I need to hook for event listener here? Is because IDA by design will load IDAPython the first thing. And so after that, I want to wait for IDAPython to be fully initialized. If we look at the IDAPython sources, we'll see that even IDAPython itself does not fully initialize until it receives the UI initting database, which simply says database initialization has started. So I really want to give IDAPython a chance as well, because I'm hooking into IDA API module. I'm adding all the new stuff into that. So this is an important step. And I make sure I only do it once, as I said. Now, what about load library? Why did I call load library? Let's talk about de-initialization. Since IDAPython is the first plugin that loads, then other plugins, at destruction time, IDAPython as well will be unloaded the last. So if we introduce some objects and so on, and somebody grab the reference to our methods and so on, once our plugin extension is unloaded, then IDAPython is unloaded, then Python, the embedded Python library will be unloaded. It might need to do some garbage collection and might call some destructors in our Python code or whatever it needs to do, but then it will not find the code anymore. So our Python extension plugin will be long gone and we'll have some invalid memory accesses. So to circumvent that, I call load library one extra time. Like this, when IDA is unloading my extension plugin, then it will not be really unloaded. Like this, it IDA thinks it's unloaded. IDAPython is cleaning up. If it needs to call into my plugin is still there in memory. Do we have to care about leaking or anything? Not necessarily. IDA is already exiting, so it's fine. The operating system will unload the library when it wants at the end. So this is important to prevent crashes. We need to pin our extension plugin so that IDA does not unload it at exit time, and so that we don't have a crash at exit time. Okay, one more thing to explain now is the scenario of calling Python from C++. We already did that one time here real quick in the passing, where I simply called eval. And now I'm gonna illustrate a bunch of use cases. So as well, if we want to call or interact with Python, we have to always acquire the global interpreter lock. The first test case here I'm showing you, how can we have our C++ call a built-in? So here we're going to call the sum built-in and pass it some Python code. We call py eval, this is coming from pybind11, and I'm getting the result as a Python object. Everything in Python is an object. So I get it as an object and then use that cast syntax to get the result as a number. And here I'm simply displaying it. The second use case, for example, suppose you want to call into Python and into a specific module. So here we're going to call os.get current working directory. In order to achieve that, first we have to get a reference to that module. So I'm calling pybind11 imports, and then I'm getting from that module the attribute getCwd into a Python object. And notice now that Python object acts like a callable, doesn't take any arguments. It will return a Python object, and simply I'm casting the result as a string, because getCwd returns a string, and I get it as a regular standard string and simply displaying it. So this illustrates how we can call a function in a module. Now suppose we want to now call similar. So these two are kind of similar. We want to call IDA API, the warning method, pass an argument. So same story, get a reference to IDA API module, then get a reference to the callable we want. So we're calling warning. And because it takes one argument, I'm passing it naturally as if this is a regular function. So really it makes programming very easy, this pybind extension. And here we have one more example. Suppose now you want to call your supporting module. So suppose your extension plugin has supporting Python code that you also want to call when your plugin is loaded or when it's ready and finished registration. So here I have my module sitting in the same folder or anywhere you want it that will be supporting your extension plugin. And here, for example, it has a class. You can have methods as well at the global scope. You can have anything you want. So we're gonna import that module and call some functions inside our custom code this time. Because this module is sitting somewhere non-standard, it's not gonna be easy to import directly. So what I'm doing here is simply appending it to the sys.pass.append. This is what we do normally. If we want to import something, there are multiple ways to import stuff that are not in the syspass or registered as packages. One way is to explicitly add the syspass. So here we're getting the reference to the sys module, getting another reference to the pass list. So sys.pass, the type of it is a list. So we get it into a pybind list object, and I append to it the location. So here the location of my module sits in that pass here. Then now we have the proper pass. So now if we call regular import, so here you simply say import my module, it will import it. And then what goes next, we're familiar with. We simply now we have the module, we get the attribute of the class name, so we're gonna get that attribute, and then after that I simply construct it. So I simply call my object class to get an instance out of it. Once I have an instance, then if I want to call something inside that instance, I have to get that attribute. So if I want to call do this, then all I do is the object instance, grab that attribute and use it as a callable. And so here we pass what it needs. So it needs a string and 2 integers, string and 2 integers. And we can get the result here. That function returns a string. So as well, once I call it, I get this result, I cast it as a standard string, and I display it. Now one last demonstration here. Suppose we're calling a function that returns a dictionary. In that case as well, we can use the same stuff. We can get the attribute to the function we want to call and cast the result to a pydict. And then we can use here the range syntax. It will give us the first and the second. This is like std map, for example. So we got the key and the value, and we cast them accordingly. So if we know our library here supporting module returns dictionary of a string, then once we iterate over the dictionary, we cast the key and the value to the proper types and just print them. If you want to clean up at the end as well, you can only do that at the end. So instead of adding the pass on the run method, maybe you do it directly after registration. So here maybe you add to the system pass, the pass to your supporting module directly after here, and you don't even have to clean up the pass since IDA is exiting anyway. So if you do it at initialization time, you don't need to clean it up at all. And finally, let's talk about how to build this. Now let's talk about the CMake. So we're gonna be building using IDA CMake and the usual stuff. So as you see the IDA CMake syntax, but we also need some additional syntax to work with pybind and also to find the Python development libraries. So an important thing I would like to mention is do not build or run this plugin in the debug configuration, because this will let us have that binary and its import looking for Python, whatever is the version, _d. And so we'll have Python 3.dll in memory and Python 3_d. That's going to cause undefined behavior, if not outright crashes. So instead use either the release or the release with debug info. So here, this is something I decided to do. You don't have to. I simply decided to disable optimization when we build with release with debug. So like this, I don't have optimized code. I can use the watches correctly, breakpoints correctly. So it makes debugging easy. If I want to distribute this plugin, I'll simply switch to the full release configuration here. Then what I do is simply call the standard CMake method here, find package, and this is something standard. I tell it the package name and it knows how to find the Python stuff. So what we really need is we need the Python include and we need the libraries we're linking against. So in the include, this is the Python C API. Normally, if we're doing everything by hand without using pybind 11, we would want to use this directly, but we're using it indirectly through pybind. And also what we want is to locate the libraries so we know what to link with. Because we're building with release or a variation of release, we're not going to be using the _d. Instead, we're going to be using either Python 3.lib or Python 3.11. Now, if we directly link to Python 3.11, then our plugin will have reference to, so we will notice we have Python 3.dll and Python 3.11. So I don't want to lock the user to a specific Python version. So we're just going to stick to the major version, not the minor version. So I'm going to show you how we can achieve that trick. And this same trick is what IDAPySwitch uses. So if we go to IDAPySwitch, we have that tool here that lets us tell IDA which Python version we want if we have multiple IDA versions. And the way it is achieved is IDAPython binary itself does not link to a specific and full version of Python. So it doesn't link to the major.minor. Instead, it just uses the major version number. We can verify that if we go to the plugins, IDAPython, and we look at the import table. And here, if we scroll, so apart from using IDA.dll, the SDK, it doesn't link to Python 3.11 or Python 3.12 and so on. It just uses this. And we're going to use the same trick. So like this, we can work nicely with IDAPython version switcher tool. So if you have any other Python 3 version, our extension plugin will work. So how does this work really? What's the difference between the two, Python 3, Python 3.11? So if we open Python 3, we look at the size, it's just 65 kilobytes versus the 3.11 is the full implementation, so it's 5 megabytes. If we look at this and look at the export table, we'll notice Python 3 acts as just a simple forwarder. So if you refer to Python 3 and load it and you call any of those methods, it will redirect stuff to 3.11, 3.11, 3.11. So this is how that happens. And if I inspect my plugin, so let's go to IDA SDK and here in plugins, and the plugin extension is going to be the same. So if we look at the import table, I'm also using Python 3. How did I achieve that? So now let's go back to the CMake script and we'll notice after I call find package, it will find the Python version and so on. I'm explicitly replacing the 3.11 or 3.12, whatever reference to the exact library version with Python 3. So this is important. I've tested this on Windows, of course, and I made a guard here. Maybe on other platforms you have to tweak it a bit, but I mainly work on Windows, so for now this should give you a good starting point. And then the rest is simple. We add the include folders as found by the find package. And also we specify the Python link libraries as well. And we also refer to pybind11. So pybind11, wherever you clone it to, you have to add subdirectory or find another CMake method to simply bring in that pybind integration with CMake. So by simply adding this, now we should be good to go. We're gonna be finding its headers and so on and so on. And this is IDA CMake syntax. We're simply saying additional link libraries is gonna be using pybind11, the embedding part, and Python 3.lib, and the rest is our plugin sources, and that should be good to go. So that's it for this video. We learned how to add Python bindings in C++, how to also call from C++ Python things, and also leverage additional module, supporting module in Python from our C++ plugin. I also explained little intricacies about the destruction time and de-initialization and how we can circumvent that. Of course, as I said, the ideal way to add functionality to IDAPython is to go and add it directly into IDAPython. But there are cases, as we'll see in the future, where we might want to have our plugin that only when our plugin is available we have those additional extensions. All right, thank you, and I'll see you next time.